Welcome to Engineering Innovations, the official podcast of Purdue University's Elmore Family School of Electrical and Computer Engineering. I'm your host, Kristin Malavenda, and today's guest is Akshita Kamsali, a fifth-year PhD candidate in Purdue ECE, working with Professor Avi Kok. Akshita's research focuses on deep learning, particularly in computer vision and natural language processing, two technologies that help machines interpret images, text, and complex information from the real world. She's also applied that work in some fascinating ways, including research at Lawrence Livermore National Laboratory, where she explored how large language models can help power self-driving laboratories. We'll talk about what those are in just a bit. And today we'll also talk about her path to Purdue, what her research looks like, and what it's really like to spend 5 years pursuing a PhD. Akshita, welcome to the podcast.
Thank you, Kristin, for a very kind introduction.
You're welcome. All true. But let's start with your story. What first got you interested in, I guess, engineering in general, and then electrical and computer engineering specifically?
Okay. So I have had a very early influence in engineering. Both my parents are engineers.
Okay.
And both my parents are first generation college goers.
Okay.
So I wish I could be the first Dr. Kamsali, but my father already has that. So yeah. But that said, like I grew up around engineering and then the scientific thinking a lot. So engineering was an obvious choice for me when I decided to go to undergrad. And then even in undergrad, I was still conflicted between engineering and science. So I was a major in engineering science.
Oh.
And then I chose to specialize in electrical engineering. What attracted to me to electrical engineering was the sheer amount of breadth. Like even in undergrad, I saw people doing nanophotonics, and then I saw people working on sensors, like analog, digital, and even AI.
Yeah.
So that kind of interdisciplinary application was what drew me to electrical engineering.
Yeah, wherever you go, they need an electrical engineer, so there's a kind of a limited amount of things you could do. Mm-hmm. But what led you to Purdue specifically for your PhD?
Oh, so I knew of Purdue through an exchange program in undergrad. So basically, I came as an exchange student here in 2019 summer as a rising senior.
Okay.
So then, believe it or not, I fell in love with West Lafayette, like the kindness of the people around here, just the infrastructure and everything. I really loved it, and then I decided, okay, I'm going to go to grad school, Purdue being my top choice. So, and I decided to go to ECE again because of the breadth. So that was my journey to ending up at Purdue.
When you first started at Purdue, did you know the research direction you wanted to pursue, or did that kind of evolve over time?
It definitely evolved over time. So the reason I kind of also know about the breadth in ECE is because I have first-hand experience in that. So I started in optics, like nano-optics, mm-hmm. where I did computational physics and where I did a lot of experimental physics as well. And then this was very valuable for me to have both computational and experimental background. And I decided I want to pursue something very computationally intensive work for my PhD. And then I chose to come to AI around 2021. Fall is when I decided that, okay, I want to pursue my PhD in the area of AI, especially with vision implementation.
Right. And as I mentioned in the introduction, your work focuses on deep learning, especially computer vision and natural language processing. For listeners who might not be familiar with those areas, what kinds of problems are you trying to solve?
My primary area of research is understanding deep learning models. So we have been deploying these AI and deep learning models in very sensitive tasks like medicine applications and security applications. So now the challenge is not just to AI making the correct decision, you also want to understand how it makes the decision.
Right.
So sometimes it could be a spurious correlation that it is making a decision and not because there is an actual reason to make that decision. So that kind of things especially are important when you're applying in sensitive tasks. So that's primarily my area of research for my PhD.
So a lot of people hear terms like computer vision or language models, but what do those machines do? What are they being used for?
That's a very good question. So when I talk to my grandparents or anybody, they think I'm doing something extremely complex, mm-hmm. but it's a very fun thing actually. It's been around for a while. Computer vision has been around for a long time. computer vision, as the name suggests, it's about how you let a machine look at an image, understand what's going on in an image. So like scene understanding, relationship, like right now there's a microphone in front of me, so you speak into a microphone. So that kind of relationship, or just looking at an image and understanding what is present in an image, what is the relationship between two or three objects in this image, localization and detection, that's computer vision. NLP, natural language processing, is a even fun way to say it is it's a conversation completer. So in the heart of natural language processing, it's almost always about generation, at least, is predicting the next token, as they say in NLP, but it's almost like finishing each other's sentences.
Gotcha. Yeah.
So my friend says this in a fun way, that he's a Potterhead, I'm a Potterhead. So for all the Potterheads out there, you're trying to build a Fred and George Weasley in a computer.
That's funny. I like that. Last summer you worked at Lawrence Livermore National Laboratory. One of the projects you worked on there involved self-driving laboratories. What is that, a self-driving lab?
So you've heard of self-driving cars, you've heard of autonomous cars. So it's kind of a lab which runs automatically, but it's not about replacing the scientist, but accelerating discovery.
Okay.
So essentially, like, there could be some harmful chemicals you're working in the lab, or for perhaps like you want to paralyze your work. So it's essentially helping you accelerate this discovery, and oftentimes computing these parameters and all of those, like it could do automatically and build the experiments for you. So this involves like a lot of modalities, not just image and text. You can also need audio. You also need a lot of depth and sensor information to do this.
So are these all different programs or machines handling, like one's handling language, one's handling vision, or is it one kind of program that integrates it all?
Yeah, so essentially if you think about it, we are one human, but we have like these five senses we keep talking about. So essentially the idea is you take a multimodal, so is capable of handling different modalities, and it takes in all these different inputs and then process them together. And then there are also implementations, like some folks may also do it like they can have separate models for different aspects, and then they can combine the decision. So there are both ways of doing it, but the way I have done it was a multimodal aspect.
Gotcha. So we're talking about the large language models and about how you're trying to help the robots I don't know if that's the right word, robots understand what's happening in the lab and make decisions as the experiments are going on. How exactly is that working?
Okay, so essentially if you think about it, when you put yourself like as a scientist in the lab environment, you need to understand like what's written on this flask or what is written on this vial, and then you also need to make sure that the color doesn't look off. You have those senses like also over time of experience, and there are certain safety aspects you have to keep in mind, and like basic physics, like you can't put 200 milliliters of liquid in a 100 milliliter beaker.
Yes.
So those basic things, again, like as we go back, natural language processing has been like next token generation. So instead of next word prediction, how do you manipulate that into making a robot understand this task? So robot is your end effector, but you want to get inputs from all these different modalities, interpret that and make a decision and convert that into an action the robot arm is performing for you.
Gotcha. Are some of these self-driving labs how close are we to those being like widespread, widely used?
There is a lot of research going on. There are a lot of autonomous systems which are deployed, but I'm not exactly sure like how many of them are large language model integrated.
Right.
There are definitely deployed in spaces. There's a lot of experiments going on. But I think large language models, at least in my preliminary findings during my internship, it needs a lot more work before we can deploy them inbuilt with all of these capabilities.
How did you get I don't know if it was an internship or the job at Lawrence Livermore, and what was it like working there?
So I applied for an internship like everybody else, like applied online, like a couple of interviews, and then they made me, I did a research presentation and they had like some technical questions. So that's how I landed an internship. I was very how do I put it? So when I came to PhD, my goal was always to work in a national lab, and then I could not believe myself that I worked at a national lab until I did. And I have EC to thank for this, like especially having that Purdue name helped. And then even at Livermore, like there are so many Purdue alumni, and they are in great leadership positions and scientist positions. So that's
great.
It's a cool brand to have on you.
Yeah, and they understand what you came from too. So
it's a lot of doors I wouldn't are available for you to step into with the Purdue name, and especially Purdue EC.
Yeah,
it's a very cool name to be associated with.
That's awesome, and especially because I imagine there's a lot of people applying for these internships, so to have any little edge you can is a good thing. One of the interesting findings from your work is that today's AI models still struggle with reliability and reasoning in real-world lab environments. What are some of the challenges researchers are trying to solve? What's the most important thing to kind of move this forward?
Yeah, so one of the most important thing is safety aspect of all of these things, security aspect of all of these things. So in the lab especially, you don't want to give clearance to everybody to be able to access those things.
Yeah.
So to establish those things, and then another aspect is like just not violating physics, like not pouring 200 ml into 100 ml,
right.
Or even if you give a malicious command to do like, hey robot, can you spill this acid on Akshita, please don't do that.
Yeah, so it has to know what to do and what not.
And then or even like so when these large language models, so they keep their logs, so you could also instruct it like, oh, cause a spill but log it accidental, like it was not caused intentionally but just log it as accidental. Should not be able to manipulate those logs. So those kind of security details are one of the top criteria, I would say. And then the second thing would be, so these vials in lab are always transparent. So a regular camera may or may not be able to capture those. Even for us, when we look at a picture, sometimes transparent objects are not clearly seen.
Right.
So you need a lot more other sensor data. So you could use some depth sensors or like these LiDARs, which can help you capture these. But again, you have to make these instantaneous.
Right.
So they can't take 2 hours to process this input. So
otherwise, what's the point?
Yeah, so like they have to be efficient. So I think to summarize, it would be security, then followed by accuracy, and then efficiency.
Gotcha. So I'm going to have to cut this and start over. I missed a... Okay, so another interesting direction for your work is combining those different types of data, like images, text, and sensor information. So why is that important when you're building AI systems?
So as again, I'll take us back to like we are capable of doing all of these different modality. Like I'm talking to you, I'm looking at you, and then I'm able to do some action. So you need that for any automated lab or a self-driving lab. You need to be able to combine all the sensor information, camera information, a voice command for that matter to, and even you have these documents like the standard operation procedure documents for a specific lab, that's all in text, to be able to assimilate that and make sure your command is not violating that. So you need all of these modalities to come together to be able to build a successful model. And also, I think that that's the next step for AI to go there to improve, is to be able to take all of these modalities in together. It's
like you mentioned before, it's like being a person. We have to intake all this stuff and make decisions, but AI can do it, I imagine, quicker and maybe more efficiently.
I do not know enough, like I'm still a PhD student to comment on that, but I would mean like, so instead of just showing an image and making the AI make a decision, you give it more information so it can make an informed decision. So that's always important, I believe. I do not know enough in this because I'm still a budding researcher in this area. But in my limited experience, I strongly believe that to make an informed decision, we always seek more information when we are creating our own opinions. So I believe like that's also a good way to make an accurate and more efficient and more secure decision.
That makes sense. You are now in your 5th year of your PhD.
Yes.
So what is the PhD experience? What did you expect it to be like? And how did it match that? And how did it maybe differ from what you expected?
So again, like high school was always structured. Undergrad, even though I kind of picked my own adventure, it was still more structured, like I had to meet a certain amount of credits. And there's a semester, you have midterms, you have end terms. There was a bit of structure.
Yeah.
But coming to PhD, I had to relearn discipline because there is nothing is on a semester timeline, nothing is on a monthly timeline.
Right.
You're on your own timeline. So I like to call it a relay marathon. So it's a one marathon followed by another marathon. Yep. And discipline is something which my father kept telling me, but I only learned it in PhD.
Yeah.
I'm still striving to be more disciplined. And timing. Timing is very important. We may be working hard. It's also sometimes you have a cute problem, you're working on it, and then 2 months into it you realize, oh, somebody already published this.
Yeah.
So it's not to be disheartened. That's why I'm in timing, and I learned to be kind to myself. I did not learn that until 4 years into my PhD.
Yeah.
And again, all Purdue EC folks are high achievers. They have been top of their class, they do well in their grades, and they're all in the grad school because they were good at some point.
Right.
So accepting that your problem had already been done is not failure, but you're on good track.
Right.
So somebody else is thinking about it. So it should be considered as a validating signal rather than a disheartening thing. And I still struggle with it every day.
Well, I think people don't understand that the PhD journey and just the research journey in general is probably more failure than it is ultimate success or roadblocks that you have to work your way around to get to the answer. So you said you're kind to yourself. How do you just say, dust yourself off and keep moving?
I think, again, I struggle with it every day.
Yeah.
I am very fortunate to have a very good support system here. Not just through my social group, also with Purdue staff, or even peers here, I can just go rant to them. And again, my advisor has been very kind to me, as very supportive. When we talk about things, they're like, yeah, it's okay. There's a little bit of conversation.
Yeah, because they've been through it.
They've been through it themselves.
Yeah, so when you work with Professor Kok, when you work with your advisor, what role does he play? How does he influence your research or support you?
So, Dr. Kok's advising style is unique, as it's to every professor. There is no set unique. That's another thing I learned at PhD. There is no two professors are same.
Right,
so,
yeah.
That's also very interesting. Your experience could be completely different. So, Professor Kok has a very independent researcher kind of style. We frame problems together, and he helps us shape the problem together. And he also gives he's been around for a long time, and there are a lot of his tutorials probably built 20 years ago which still are grounded in fundamentals. They help you ground yourself in fundamental research, but also do really advanced applications. So in my lab there have been researchers who've done language processing, they've done robotics, they've done computer vision.
Right.
So it's been a journey.
Yeah, and learning a lot about different areas too, like that interdisciplinary aspect. You chose to do a PhD. What would you tell somebody who's trying to decide, what qualities do you have to be successful in a PhD?
Number one, patience.
Yeah.
So you can't expect the results in a year. A PhD is not a linear process.
Right.
That is not in a negative way, but in a more, you have to think about it. So not everything in the world, it's not a reward system. You give an exam, you don't get a score immediately.
Okay.
There's a slight review process. You go back and forth with an idea. That's how you're trying to change the world. You're trying to discover something new.
Right.
So that's not a linear process. It's rewarding. You want to, you're a very curious person, and you could also do PhDs in different aspects. You can be a very theoretical researcher, you can be a completely applied researcher, where you're building a product. So I would recommend doing a PhD if you are very curious and you want to get your step out there and you want to do that. And you should not restrict yourself that, I need to have an A+ in calc to be able to do a PhD. That's not really the case. There are a lot of PhD students who don't need to do any pen and paper work, and they do a lot of computational work.
Right.
Some do a lot of experimental work. It's about your intuition and perseverance which matters more for PhD than just intellect. There's a set amount of it. Like you're in undergrad, you're in doing your master's, so you have already crossed that bar.
Right. Yeah. So believe in yourself if you can do it. Do you know what you want to do? Like, do you want to stay in academics? Do you want to go into industry after you? Or are you still trying to figure that out?
So, when I started my PhD, I definitely wanted to go into academia. But then during my PhD, I learned that academia is not just about doing research. You raise a lot of money. So these are all the things you wouldn't know as a student.
Right.
So, and then I realized, okay, maybe I want to be an individual contributor for the first few years of my career. So I'm currently looking to some independent researcher roles, like a research scientist or applied scientist, those kind of things, straight out of PhD. And then if things work out, I'll come back to academia.
Yeah, and that's the other thing too, is you don't have to know what you're going to do for the rest of your life. You can try something out. If it doesn't work, go the other way. So what do you like to do in your free time?
What do you mean free time?
Well, I guess when you're not chained to a desk.
So, yeah, I'm pretty much into my desk. I do have some free time. I mean, again, it's free time is something you make for yourself.
Right.
Again. So I do try to make free time. So I love taking walks in Celery Bog. That's my favorite.
It's pretty there.
Place in town. And then I bake a lot. Like, I've recently got into sourdough, so I have a little pet in my fridge, and then I bake a lot. And I've always loved cooking, so the cooking has been my go-to free time task. Like, I experiment with fusion recipes. Like, I'm from India, and I'm from southern part of India, so I experiment with like the local produce, and I have a couple of like American friends here, so whom I try to introduce them to the Indian cuisine, but through the ingredients they're already familiar with.
Right. And Indian food as opposed to American's version of Indian food. More than just tandoori chicken or something.
So I'm from South India, so we have a lot of coconut-based dishes.
Oh, okay.
We have a lot of peanut and sesame-based dishes. So those are the kind of unique flavors I try to bring in. And one of my friends here in town, Charlie, he kind of introduced me to this pork and sage goes very well. Mm-hmm. And there's this Indian pickle, ginger pickle.
Oh.
And he made a rub out of that ginger pickle, and that had such a great glaze.
Yeah. Well, see, you could go into cooking. You can bottle that and sell it. Well, thank you so much for joining me and sharing your research and your experience as a PhD student.
Thank you so much, Kristin, for having me.
And thanks to our listeners for tuning in to Engineering Innovations, the official podcast of Purdue University's Elmore Family School of Electrical and Computer Engineering. If you enjoyed this episode, be sure to subscribe to the podcast, share it with someone who's also interested about these subjects, and you can also leave a comment and tell us what you'd like to hear about on the podcast, or if there's a specific person you'd like me to have on the podcast. And thanks again for listening. Until next time, I'm Kristin Malavenda.